So we're going to start by factoring with the greatest common factor, okay? That means a number that is common in all parts of the problem. So for example, we're going to start out by just finding the greatest common factor. We want the largest number that goes into both 48 and 72. So like looking at this, I know they're both even, so I know that 2 goes into them. But 2 is not the largest number that goes into that. I want to find the biggest number. So some of you guys will be better at this than others because you're good with your multiplication tables. And some of you guys will have to write some things out. So let me give you an idea of a process that would help. What I usually do is pick the smaller of the two numbers, and let's write out factors of 48 first. Write out factors of the smaller of the two numbers. So I know like 1 times 48 is 48, right? And I know that 2 times 24. And you know, you could even use your calculator to see if 3 goes into 48, which it does, because it goes into 30 and it goes into 18, so it goes into 48. So it goes into 30 10 times and into 18 6 times. So 3 times 16 is 48. 4 times 12 is 48. 5 doesn't go into it. Does 6 go into 48? Yeah, right. 8 times 6 is 48. So 6 and 8. And once you get those numbers that are close together, you know, then 7 is in between 6 and 8, and 7 doesn't go into 48. So these are all of the factors. So I know it's a lot, but usually the smaller number has the less factors. But we want to know which of these also goes into 72. So you could either rearrange them from, you know, largest to smallest if you wanted to, or we could just start to pick them off. The biggest number is 48. 48 does not go into 72. That's not the answer. So then I look for the next biggest number, 24. 24 go into 72? So how many times? 3. 24 times 3 would be 72. And so then our answer is 24. If 24 didn't work, then I would choose the next biggest number, 16. If that didn't work, the next biggest number. And kind of work your way because we want the greatest common factor, work from largest number down. Okay? The numbers, if you look at part B, it looks like it's going to be harder, but it actually isn't. The numbers are the hard part. The variables, I'll show you what to do. That's the easy part. So for part B, I want to find the greatest common factor. I'm going to look at the numbers because I need to find the GCF of 7, 49, and 28. So I pick, you know, the smallest number, which is 7, and I'm going to look at 1 and 7. That's a prime. Okay, those are the only things that go into that. And work from the largest number down. Where 7 is bigger than 1. Does 7 go into 49? Yeah, it does. Does 7 go into 28? Yeah, it does. So 7 is our number. All right, do you guys get that? Because that's the hard part. I'm going to show you the rest of it. But are there any questions yet on the 7? When it comes to the variable, you choose the smallest exponent, which is x squared, where GCF is 7x squared. Okay, for the variables, you always choose the smallest exponent. All right, for part C, similar, well, we got 3 parts here, okay? So first, I'm gonna look at the numbers. I have 42, 3, and 1. Well, that's kind of nice because 1, is only 1 times 1, right? And so I know that 1 goes into everything, so I'm just that's gonna be my number part. For the variables, we have x's and we have y's. For the x's, I have x to the 3rd, x to the 5th, and x squared. So I take the smallest exponent, which is going to be x squared. Okay, just take the smallest exponent. For the y's, I have y to the 1st, y squared. And I know you wouldn't even really think of it this way. That's actually y to the 0. Like there's no y's on the end, which means we can't have that as part of our common factor because it would have to be common in all of those. So our answer is just 1x squared. We don't even need the 1, so I'll make that part of my box here. Our answer, I'm just going to write as x squared. All right, any questions yet? Okay, so problem A here below is a lot like this first warm-up problem that we did, where we want to pull out the greatest common factor. So I would look at 5 and 20. And my GCF, my greatest common factor, would be 5, okay? Because 5 does go into 5, and 5 goes into 20. So what I want to do is I put my common factor out in front, and then in parentheses, I write what's left over after I take the 5 away. If I take a 5 out of there, I have an x. And if I take the 5 out of there, I have 4, because we're talking multiples here. And so what I get inside the parentheses, I have an x minus, and 5 times 4 is 20. And that is our answer. So again, we're moving backwards from the distribution. Now, you guys were good at distributing, so if you wanted to, distribute that 5 through and see if you get back to the original, which we do. So you can check your work in that case. All right, for the next problem, let's change this 3x squared up front. Let's make that a number different than 2. We'll make it a 12. I'll add a 1 out front there. So let's make that 3x to the 12th. Why? Because it was an x squared, and the one next to it was also an x squared. So usually we would combine those first, and it's kind of a different type of problem. Okay. So let's look at the numbers first. We have 3, 6, and 3. Well, 3 is going to be the greatest common factor of the numbers. Now remember, for our variables, we take the smallest exponent. We have x to the 12th, x to the 2nd, and x to the 1st. So x to the 1st is our smallest exponent. So 3x is the GCF that I'm pulling out for writing that in front. All right, so if I take 3x out of here, well, the 3 is gone, so that's good news. And if I take 1x out of x to the 12th, I would have x to the 11th. Because again, remember, if we distributed that, we would add exponents, giving us 3x to the 12th. For the middle term, I'm taking 3 out of 6, so I'm going to be left with a 2, because 3 times 2 is 6. And I'm going to need an x, because x times x would be x squared. So 3x times 2x would be 6x squared. And now last but not least, if I take 3x out of 3x, I know you'd say, well, there's nothing left over, but we really need a +1 placeholder. Because again, think about distributing. This is our answer, by the way. And if we were to distribute that, that would give us 3x to the 12th plus 6x squared plus 3x, which is the same as our original. All right, so we got one more here. So for the last one, our numbers, the largest number that goes into 8, 4, and 16 would be 4. For our x's, we're going to take the smallest exponent, which is x squared. For our y's, we're going to take the smallest exponent, which is y squared. So we're pulling a 4x squared y squared out. So for that first term, if I take a 4 out of 8, I'm left with 2. And I took x squared away from x squared, so I don't need anything because I have my 2 there. And if I take y squared out of y, I would need 1y. So again, just to check, this times this would be 8x squared y to the third, which was our first term. Now to do the middle term, I take 4 out of 4. So I might need a 1 placeholder, but I'm going to wait and see if I have anything else. Because if I take x squared out of x to the fourth, that's going to give me x squared. And so y squared out of y squared, I don't have to write anything. So again, this times the middle term is -4 x to the fourth y squared. So my middle term's looking good. And now last but not least, taking 4 out of 16, I have 4. I need an x so that my x squared becomes x to the third. And I need a y squared so that my y squared becomes y to the fourth. And this would be our final answer. All right, any questions on those?